Hi everyone, I'm T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series video, we are going to discuss about replacement problem from quantitative techniques. So before that, what is a replacement problem? Suppose the all equipments are put to continue use which reduces the efficiency of the equipment. The study of replacement is concerned with the situation that the arise when some items such as machine, electric bulbs, electrical light, and so on need replacement due to their determining efficiency, failure, or breakdown. So the deterioration's efficiency or complete breakdown may be either gradual or all a sudden. In all such situations, there is a need to formulate a most economic replacement policy for replacing faculty meant or to take some remedial special actions to restore the efficiency to retaining the units. So the replacement is also need for equipment if the cost incurred in such operations and maintaining the equipment exceeds the benefits derived out of it. The objective of the replacement problem is therefore to determine the optimal time at which the equipment is to be replaced with a new one. So in the replacement, there are two. One is a replacement of item that deteriorate with time, and another one is replacement of time with a fall certainly. In this first one, the replacement of item that rotate with the time, ignoring time valuable for money and considering time value money. And on that next replacement of time that falls suddenly is individual replacement and also the group replacements. In this lecture series video, we are going to discuss about the problem based on the individual replacement policy. Okay, so we shall consider the following two steps of replacement policies. One is individual replacement policy and another is group replacement policy. So in this first case, there are different kinds of decision is there. So when the machine or when the item is replaced, that we discussed. Okay, so suppose we consider for C. So C means the capital cost of equipment. S is the scrap value of equipment, and N is number of years that equipment would be in use. And the F of T is a maintenance of cost, and A of N is the annual total cost. Okay, now we consider the problem. A firm is considering replacement of a machine whose cost price is rupees 12,200, and the scrap value is rupees 200. The remaining, that is the maintenance or and operating cost, are found in the experience as follows. Here, there are 1, 2, 3, 4, 5 to 7, 8 years. Running cost is in first year 200, second year 500, third year 800, fourth year 1200, fifth year 1800, and sixth year 1500, seventh year 3200, and eighth year the 4000 rupees. So, when should the machine be replaced? By these conditions, when the machine should be replaced. So, we discuss this case. Now, we take what is C, there the cost. The cost is that is a maintenance cost or the cost of the machine is rupees 12,200 and the scrap value is already given, it is 200. So, we form the table. First, we write the year 1 to 8 and the running cost is already given 200, 500, 800, so on. So now next, the first year 200, what is the next year? It is 500. So total running cost is 200 plus 500 is 700 that we calculated in the terms of cumulative running cost. So how we calculate that? First write this 200 and add 200 with the next running cost of second year is 500, that is 700. And the third year running cost is 800. Add with this the cumulative value is 700 plus 800 is 1500. And the fourth year running cost is 1200, but the cumulative cost is 1500. So add these two, we get 2700. Likewise, other all 8 years. So the depreciation is also given. So 200, so 1200 and 200 is a scrap. So subtract this. So the machine cost is 12,000. So but therefore the depreciation cost is 12,000 in each year. What's the total cost? We add the depreciation and also the cumulative running value. That is 200 plus 1200, 12,000. It becomes a 12,200. And the third value is a 700 and the 12,000, 1200 or 12,000. So 12,700. Next, For a third year, 1,500 is a cumulative cost and its depreciation value is 12,000. So total it is a 13,500. Likewise, other all 8 years. Next, we calculate what is the average total cost. The average total cost is calculated from the total cost divided by the years. So that is in fifth column, we have the total cost of the machines and divide each year. So 12,200 by 1 is 2,000. 12,200. Next, second year is 12,700 divided by 2, we get 6,350. And the third year, 1,500 divided by third year, 3 is 4,500. And the next fourth year, total cost is 14,700. Divided by 4, we get 3,675. Likewise, we calculate all the succeeding years. So we conclude that first cost, average cost is 12,200, second is 6,350, fourth 4,500. So year by year, the average cost is reduced. But at the certain stage, in the sixth year, certainly the cost is in sixth year, up to sixth year, the cost is average cost is decreased. After the certainly seventh year, the average cost will be increased 3,171. Therefore, in sixth year, we have the optimal due. We have replaced the machines after 6 years. So 6 years due is a minimum. So that is the problem for this. And next we get the second problem as usual. The data collected in the running machines, the cost for it is given 60,000. So the resale value of first year, second year, third year, fourth year, fifth year, and also cost of spares and labor charge, everything is given. So determine the optimum period for the replacement of the machine. So as usual, we first write the 5 years and the running cost is already given. We write all the running cost and the cumulative cost as usual we calculated 18,000 and add with the second year running cost is 2270 with 18,000. So we get 38,270. Likewise, all the 5 years. Then resale value. So we calculate resale value is 42,000. Next year is 30,000 and 20,000. So everything is given. So depreciation cost is we calculate just C minuses. That is already it is 18,000 and we subtract that it is 30,000. Next to 39,000, 45,600 and 50,350. So what's the total cost? We add the third column and the sixth column. That is a total. We add fifth column and the third column. So third column cumulative value and the fifth column value is depreciation cost. Add these two, we get a 36 and so on. And as usual, by the previous problem, we calculate what is the average total. Average total is the fifth column value. That is total cost divided by the number of years. That is 36,000. In the first data, 36,000 divided by 1 is 36,000. Second data, 68,270 divided by 2, we get 34,350, 103.35. And third year, 33,583. Fourth year, 33,362. And fifth year is 34,000. So compare all this. In the first year, second year, average cost is decreased. Third year cost is decreased. Fourth year is also decreased. But suddenly fifth year cost is increased. Therefore, the fourth year is the best replacement tube. That is way. So from the above table, we see that the average cost is a minimum at the end of the fourth year. Therefore, because fifth year rate is increased, and therefore the best replacement tube is after 4 years because its cost is 33,362. Then it is increasing. The next data is increasing. Therefore, we stop at this level. Therefore, fourth year the replacement tube is the best one. Thank you for watching this video.